Hi, in this video we are going to see about a Python IEEE project which is entitled as Smart Diabetes Prediction System using Machine Learning Algorithms, which is an enhancement of IEEE base paper titled Improving Healthcare Prediction of Diabetic Patients using KNN Immutated Features and Tri-Ensemble Model, which is an IEEE 2024 journal paper. This is an IEEE access paper. This is a 2024 IEEE journal paper. So before seeing the execution of the project, let me brief about this project. So we all know about diabetes. So diabetes is a very worse disease that is causing many of the humans in the world nowadays because of the various reasons like change in the lifestyle, change in the food habits, lack of exercises, sleep, etc. So the main problem of this diabetes is it may be said as the silent disease because the people would have not known about whether they are affected by diabetes or not, only if they have been had some worse reactions or the conditions. So identifying the diabetes in the early stage will help the people to recover it or to reverse it. So in this base paper, the authors have implemented the prediction of the diabetes using the machine learning algorithm. So in this base paper, the main study is to propose an automated method for predicting the diabetes. So the authors have used K nearest neighbor immutated feature along with a tri-ensemble voting classifier model. So using this, they have achieved the accuracy of 97.49%. And kindly note that we are not going to do the same as mentioned in the base paper. So now let us see about what we have improved from the base paper and what are all the models that we are going to do from the base paper. So first let us see about the models and the performance that we have achieved. So we are going to use 4 distinct models. The first one is stacking classifier, second one is ExtraTree classifier, third one is LGBM classifier, and the fourth one is CatBoost classifier. And coming to the accuracies that we have achieved, you can see the stacking classifier achieved accuracy train score of 99% and test score of 92%. ExtraTree classifier achieved accuracy train score of 100% and test score of 93%. And LGBM classifier achieved accuracy train score of 100% and test score of 95%. And finally, CatBoost classifier achieved accuracy train score of 100% and also the test score as 100%. So the first thing is we have improved the accuracy. We have used 4 distinct models. And coming to the data set part, so in the base paper they have used PIMA Indian diabetes data set. So in this data set they have used 768 instances, but we are going to use the same PIMA Indian data set, but it contains the 1382 data set records or the instances. So this is the data set that we are going to train the model. So here you can see the data set contains the features like pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and the outcome, which is a diabetic or not. So you can see the description that is mentioned in the base paper also. So you can see the age is in years, the class, that is the target, is diabetic or not. The glucose, you can see the level of the plasma glucose, and the body mass index you can see weight in kgs and height in meters. Insulin you can see the value is u bar ml. Pedigree function is the diabetic pedigree function which shows the history of the patient history of their family and generic kind of thing. And pressure you can see it is a blood pressure which is calculated in mmHg, and skin thickness you can see it is mm, and pregnant is the number of times the pregnant asked by the patient. So this is the detail of the data set part. So now let us see about the proposed system document. So here you can see the proposed system title and the IEEE base paper title. This is the IEEE base paper abstract. Coming to our proposed abstract, so the abstract starts with giving an introduction about the diabetic and the importance of early detection of the diabetic. And coming to our system, smart diabetes prediction system is developed using Python. And for the front end part we have used Flask web framework which contains front end build using HTML, CSS and JavaScript for the seamless user experience. So the system utilized 4 powerful machine learning models: stacking classifier, ExtraTree classifier, LGBM classifier and the CatBoost classifier. And as mentioned, we have used the enhanced PIMA Indian diabetes database which contains 1382 dataset records with these features of it. So here you can see the accuracies that whichever we mentioned that has been mentioned, and finally we have summarized the details in the abstract part. And coming to the existing system, so we are taking the base paper as the existing system. So this is the base paper. So here in the base paper they have used k nearest neighbor, k and none imitated features with try ensemble voting classifier model. So they have used this model, and the existing system model is based on the stacked ensemble voting classifier, which is combining 3 powerful machine learning algorithms like XGBoost, random forest and the ExtraTree. So these are the try ensemble voting, and they have used these models for the prediction of the diabetes. And the data set, they have used PIMA India data set with 768 data set records, and the accuracy they have achieved is 97.49. So those details have been described in the existing system part. And coming to the disadvantages of the existing system, so there are various disadvantages available. The main one is they have lesser accuracy than our proposed system, and they have dependence on the imitation of missing data, limited data size, model complexity and computational cost, lack of real-time predictive capabilities, limited generalizability across different population, overfitting risk with ensemble models, limited handling of feature interactions, or the various disadvantages have been described in this part. And coming to the proposed system, so we have detailed about the proposed system model with the front end part technical details, and also the model part with the accuracy of those model parts and their efficiencies details on the data set part, and everything has been summarized. And you can, next coming to the advantage of the proposed system, you can see the various advantages. The main thing advantage of proposed system is we are using 4 different models, all are with good accuracies, and we are using enhanced data set part, and we are using a good web interface with the HTML, CSS, Flask part, and we are integrating the machine learning model with it. So overall it is going to be a advanced machine learning model with a comprehensive data set with a user friendly web interface to deliver a good prediction system. And coming to the system architecture, you can see the input that we are going to give is PIMA Indian diabetes data set. The pre-processing feature selection will be made, and the model will be trained using stacking classifier, ExtraTree classifier, LGBM classifier, CatBoost classifier. The predicted result will be whether it is diabetes present or no diabetes, and finally we'll be showing the performance analysis and the graph part. So this is the overall system architecture, and this is the system requirements which contain the hardware requirements. These are the minimum hardware requirements and software requirements. So this project can be developed and be executed in Windows 10 or 11. The coding language that we have used is Python 3.12.0. Web framework contain Flask, and the front end part contain HTML, CSS, and the JavaScript. So reference, this is the IEEE base paper reference part. So now let us execute the project. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirement file with the exact version of the Python and the libraries installed in your system. So now go into the source code location. Inside that we have the smart diabetes prediction. Here in the command prompt type cmd and click enter. So now the command prompt window open the exact location of it. Now type Python app.py and click enter, and kindly wait for a few minutes. So now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome. Now paste it and click enter. So now you can see the project home screen or welcome screen with the project title Smart Diabetes Prediction System using Machine Learning. So just click this login menu. It will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and then click the login button. So now you can see the login success message and click OK. So now it will be navigated to the upload part where you need to upload the data set. So just select this choose file option. So in the source code folder, select this upload.csv file and then click the upload button. So now after uploading, it will be navigated to the preview part where you can preview the data set that we have uploaded. So whatever the features that we have mentioned, so you can see everything, and you can scroll down and you can check whether the complete data set has been loaded into the preview part or not. So as mentioned, so 1382 data set records have been loaded, and now click to train or test button, which is in the end of the page, and kindly wait for few seconds. Now you can see the training finished message and click OK. So now it will be navigated to the prediction part, which is the important part of the project. So here in the last feature, you can see we are given select model, and also we are given a drop down which shows the 4 models: stacking, classifier, LGBM, CatBoost, and ExtraTree. So you can enter the details and you can select whichever model you wanted, and accordingly the results will be shown. So let me show you with a few cases. So now let me show you the first case with the pregnancy as 0, glucose as 118, blood pressure as 84, skin thickness as 47, insulin as 230, BMI as 45.8, pedigree function as 0.551, and age as 31. So now let me select the model as stacking classifier and click the predict button. So now it will be navigated to the result page where it will be showing the input values whatever we have entered. So I have entered these values, so everything will be displayed here, and here you can see the model that we have selected as stacking classifier, and finally you can see the prediction result, that is diabetes present. So this person has the diabetes. So here we are given the option of downloading, exporting this result as a PDF. So just click this download PDF. So let me save it in the desktop as one save. So it will be exported as one.pdf. So here you can see what all the values that we have given, and you can see the model, the predicted result of it. So in this way you can just compare the results. So now what I'm going to do, I'll just check with other case. So let me click the prediction menu again. So now let me give another case with the number of pregnancy as 3, glucose level as 88, blood pressure as 58, skin thickness as 11, and insulin as 54, BMI as 24.8, pedigree function as 0.267, age as 22, and let me select this time as a model as LGBM classifier and predict. So now you can see the values that we have entered, and you can see the prediction result is no diabetes. So you can just download this for future reference also, as mentioned earlier. Let me go to the prediction menu again. So this time I'll show you a case with the number of pregnancies 7, glucose 196, BPS 90, skin thickness as 0, insulin level as 0, BMI as 39.8, pedigree function as 0.451, and age as 41. And this time let me select the classifier as CatBoost classifier and click the predict button, and now you can see the result, and you can see it is a positive case, that is the diabetes is present. So you can download this PDF if you wanted. And now let me go to the prediction menu again, and I'll show you a final case with the pregnancy 1, glucose level 124, blood pressure as 74, skin thickness as 36, insulin level as 0, and BMI as 27.8, pedigree function as 0.1, age as 30, and finally I'll select the model as ExtraTree classifier and click the predict button. Now you can see the predicted result says that it has no diabetes. So now let me export the result for the future reference. So here you can see all the results that we have exported is shown. So I have shown you with 4 cases where 2 cases has the diabetes, 2 cases does not has the diabetes, and also I have selected each 4 cases I have selected each model. So in this way you can check with the test and the train data set with the various features, various cases, and you can check with the model selecting also. So in this way you can just show the various results accordingly. So now let us move to the next part. So the next part is the performance analysis part. So in the performance analysis part, we'll be showing the performance analysis parameter for all the 4 models. So here you can see all the 4 models. Now let us see one by one. The first performance analysis that we are showing is stacking classifier performance analysis for the class 0 and 1 with the recall and F1 and the precision value for it, and confusion matrix for the stacking. This is the confusion matrix for the stacking classifier. So then comes the LGBM classifier performance analysis for the class 0 and 1 with the recall F1 and the precision value. And then comes the confusion matrix for the LGBM classifier. And then the third model CatBoost classifier performance analysis with the class 0 and 1 with the recall F1 and the precision value. And here you can see the confusion matrix for the CatBoost classifier. And finally the ExtraTree classifier performance analysis for the class 0 and 1 with the recall F1 and the precision value, and the confusion matrix for the ExtraTree classifier. So in the performance analysis part, we have the performance analysis parameter with the recall F1 and precision for all the 4 stacking classifier, LGBM, CatBoost and the ExtraTree classifier, and also we have the confusion matrix for the stacking classifier, LGBM classifier and CatBoost classifier and the ExtraTree classifier. So this is about the performance analysis part. And finally coming to the chart part, kindly note that this is a static chart. So here we will be showing the static visualization chart. So first comes the model accuracy comparison chart. So here you can see the model scores for all the 4 models with the train and accuracy scores. So first comes the stacking classifier with the train accuracy 99 and test accuracy 92. Second, the ExtraTree classifier with the train accuracy score of 100% and test accuracy of 93%. So third comes the LGBM classifier with the train accuracy score of 100% and test accuracy score of 95%. Finally comes the CatBoost classifier with the train accuracy of 100% and test accuracy of 100%. This is the first chart, that is the model accuracy comparison chart, and second one is the class distribution chart. So here you can see diabetes. This is the data set that we have taken, contains diabetes and no diabetes. So in the data set we have 68.2 with no diabetes and 31.8% as the diabetes. So that class distribution chart is shown. And then comes the outcome frequency chart, which has the outcome 0 or 1 in the x-axis and the count in the y-axis. And then comes the age density plot, which shows the age and the density. And then comes the diabetes pedigree function density plot, which shows the diabetes pedigree function and the density of it. And then comes the BMI density plot, shows the BMI and the density. And then shows the insulin density plot with the insulin values in the x and the density as y. Then comes the skin thickness density chart, which shows the skin thickness part in the x-axis and the density part in the y-axis. And comes the blood pressure density chart, shows the blood pressure in the x-axis and density in the y-axis. And glucose density plot with the glucose in the x-axis and the density in the y-axis. And pregnancy count chart, which shows the number of pregnancies and the count of it. And finally the correlation matrix with the features of pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and the outcome has been shown in this part. And now let me log out. And finally let us see about the frequently asked question. So based on that you can answer it in your YY. So the first question is, what is the primary objective of the smart diabetes prediction system? So the main objective is to predict the diabetes of the individual by analyzing their health data through the machine learning model. So this system uses the key indicators like glucose level, BMI, and age, etc. for the accurate prediction and the early detection for the better health management. And second question, what all the machine learning models used in the project? So stacking classifier, ExtraTree classifier, LGBM classifier, and the CatBoost classifier. So each model has the unique strengths, and together they enhance the overall accuracy in the prediction system. The third question is, why was the enhanced Prima Indian diabetes dataset was chosen for this project? So this enhanced Prima Indian dataset contains 1382, where the normal one contains 700 around 700 dataset records. So we have chosen this enhanced Prima dataset for the better accuracy, so that the provides a diabetes related feature that are highly relevant to this study. And the fourth question is, what accuracy was achieved by each of the machine learning models? So stacking classifier achieved train accuracy 99, test accuracy 92, ExtraTree classifier achieved train accuracy 100%, test accuracy 93, LGBM classifier train accuracy 100%, test accuracy 95, and CatBoost achieved train accuracy and test accuracy 100%. Fifth question, what technologies were used for front-end and back-end? So we have used Python as a back-end, front-end part can HTML, CSS, and the JavaScript. And sixth question, what is a stacking classifier and why it is used in the system? So a stacking classifier is an ensemble learning method that combines multiple classification models to improve the accuracy. By stacking or combining predictions from several models, it leverages their strengths and reduces the weakness, resulting in higher predictive performance. So in this project we have used the stacking classifier, contributes to robustness for the diabetes prediction. And seventh question, what are all the main features of the Prima Indian diabetes database used in this project? So the pregnancy, which shows the number of pregnancy of the individual has had, glucose as the blood glucose level, blood pressure level is the blood pressure, skin thickness is a measurement of the skin fold thickness, insulin means blood insulin level, BMI is body mass index, diabetic predictive function is family history and genetic risk indicator, age is age of the individual, outcome is the positive or the negative. Explain the role of CatBoost classifier in the system. So the CatBoost classifier is a high performance gradient boosting algorithm that handles categorical data efficiently without extensive pre-processing. So it has achieved the best of all by 100% of the train and the test. How can this system contribute to the healthcare? So this system can serve a valuable tool for the healthcare provider by assisting in the early detection of the diabetes, enabling timely intervention in the personalized treatment plans also. So what all the challenges did you encounter developing the system? So the key challenges include missing data, achieving high accuracy across diverse models, and ensuring the user interface was accessible to non-technical user. So these are all the main challenges you can answer. How does this project differ from the existing system? So as mentioned, we have additionally we have used for different models, and we have used PIMA Indian data set, and we have enhanced the accuracy from the existing system. So what the final question is, what future enhancement can be made to the system? So the future enhancement can be involved like incorporating the real-time data from wearable devices instead of entering the value. So we can integrate wearable devices by adding more features related to the lifestyle and genetics also, and adapting the system to predict other health condition beyond the diabetes. Or instead of only diabetes, we can also enhance the system by from other diseases also. So in this way you can answer it. And this is all about the project Smart Diabetes Prediction System using machine learning algorithms. And thank you for watching.